Welcome friends to the online course on HSC practices in offshore and petroleum engineering. We are discussing lectures on module 2. Where we are focusing on operational safety. This will be the 21st lecture where we are going to focus on FMEA. As we already discussed, FMEA abbreviates for failure mode analysis. This is one of the interesting tools to study the hazard present in a mechanical models, so that those hazards can be removed in the design stage itself. However, before looking into the details of an FMEA and applied example on FMEA, let us try to revisit slightly the safety concept more in particular, and then realize the importance of such analysis in hazard mitigation. If you look at the importance of safety, interestingly, safety violation actually is an alignment of mistakes, I could say. Let us say an individual in a group or set of people keep on violating the safety norms. Let us say there is a procedural violation being followed by the individual people. Let us say individual people procedurally violate certain safety norms working in a workplace or an industry or on board. Then they will of course work in a closed group. So, the closed group will have no consequences seen as inter-individual relations. Okay. For example, the safety protocols violated by individual is not shared, communicated, and the consequences are not felt in the group where these individuals are working, and we call this inter-individual relationships between the groups are missing in terms of understanding the consequences of safety violation, because there are no communication protocols present and there are inadequate shift handovers. Let us say the shift handover is not professionally done, there are some lack of communication between the group, what we call inter-individual relationship, and therefore the safety practices which are violated by the group is not communicated amongst each other to realize the consequences that may arise because of this. Now, they work in an environment which contains facilities and equipments, that is the environment where they are working, and there can be some fault in the mechanical equipments, there can be lack of maintenance, there can be even administrative oversight also. What I mean to say, in case of any report made by the near miss events of these people in the group, because of the equipments and tools and equipments used in this layout, let us say the administration has oversighted them and they did not focus, and there may be presence of poor alarms, absence of signboards, etc. Let us say these are the possible violations what can happen in the facility level or in the equipment layout level. Now, this whole unit is working in a sector which is much larger than this group, and this sector is the organization, or even you can call this management. Now, at the management level there can be certain oversight, no report of near miss events, let us say lack of training and workshops. There can be also maintenance errors, lack of proper schedule of maintenance, all can happen at the organizational level, which is now housing the facilities, individual people and the group. So, you can understand here different tiers, different levels. The first level started with the individual, then it started with a group of people, it started with the plants and equipments, it started with the layout of the organization management. Each level people start violating safety norms by ignorance or by knowing terms, let us say, but they do only a small minor deviation from the safety norm. Now, this entire system is encompassed in a bigger plane. Now, we can call this plane as the environment. Or the workplace, let us say. There may be faults present in the workplace facility which may lead to uncomfortable situation, hazardous scenarios, maybe the sea state may be rough, maybe the situation in terms of operation facilities may be hazardous, etc. Now, the safety violation happens only when all the mistakes are aligned at one shot, okay, when all of them are aligned. When each one of them are done or happening individually, when there is no intercommunication between each one of them, then there is no accident. When all of them are aligned, for example, an individual making a mistake is aligned with a group who makes a mistake, which is further aligned with the plants and equipments, which is exactly having some maintenance problem, which is further aligned with the larger group, which is the management oversighting, which is then added to a complication present in the environment, it leads to what we call as an accident. Sometimes if the consequences are not very serious, it is an incident or an event. If the consequences are very serious, we call that as an accident. So, accident is nothing but alignment of mistakes done from an individual level till the environmental support through and through, including the management tier as well. So, safety practice or HSE practice in general is actually to break this continuity. At different levels, safety practices should be implemented so that this continuum chain in terms of getting aligned is always attempted to be broken. So, that is what we say importance of safety. So, the safety importance is imparted or given at different tiers in the system, so that at least if one violates, the other takes care of. If the other also grouply violates, the third system takes care of, and so on and so forth. So, hazard scenario is an identification which is to be done at different tiers. Maturity of that will become a risk which violates safety norms, which is a very serious concern, because the consequences caused by such incidents or accidents, especially in oil and gas industry, are very, very high. Having said this, let us now discuss an important tool for doing hazard analysis in terms of qualitative methods, where I am going to assess the faults in a mechanical system at the design stage. Fmea is actually an alternate method of hazard assessment or hazard identification, we should say. This method considers all possible outcomes from failure modes. Now, then the question is, what are failure modes? Failure modes are nothing but deviations from the design objective, which is also common in case of an hazard study. This study is highly suitable for mechanical systems and electrical systems. Possibly this is one of the most powerful tool which can do hazard analysis for mechanical and electrical systems compared to any other existing methods available in the literature. As we saw, hazard study is available for chemical processes. Similarly, this method is also an hazard identification method which can be very comfortably applied to mechanical and electrical systems. This can be applied at different level of complexity. That is, starting from the design stage to that of the end final product release, you can apply this kind of study to any level or different levels of complexity. Fmea actually identifies systematically the consequences of component failure. Please understand, this method does not explicitly bring out the product failure or the whole system failure. It tells you in breakup the failure of each components present in the system. So, it determines the consequence of the component failure on the overall failure of the complete system. Most importantly, the system is helpful in grading the overall performance of the complete system through the component failure mode. That is why the study is called failure mode, which is happening at the component level, and its effect. That is why it is Fmea. This can identify equipment failure very effectively. In this study, each failure mode will be examined that may be present within the system. Then effect of these failure modes on the overall performance of the system will be assessed. So, it will be done in stages in sequence. The study is done in sequence, and it actually identifies the critical components of the mechanical electrical systems in its order of failure. That is very, very important. The component which is highest critical or most critical, let us say, will be identified, and that component can be focused in the design either to replace the component or to redesign the system with a different component, and so on and so forth. So, it will give you an order of failure. So, ultimately Fmea gives you what we call as a risk priority number, which tells me the hierarchy of failure in terms of its consequences and the chain effect of one failure on the other. So, it will also help me to understand the cascading effect of failure of components on the overall failure of the system. Let us see the methodology. What are the steps involved in carrying out FMEA? First step, define the system. Define the system includes have a shop drawing, specification of components, if possible a scaled model of the system. So, we have to define the system first in detail. Second step, identify the functional relationship of the components with the system. Also identify the performance requirements of each component. That is what we call as design intent. What are the performance requirements of each component should be identified in the beginning. Step number 3, establish the level of analysis. Is the component or the product is in the design stage, is it in the modification stage, is it in the exit stage? I mean, you do not want this product anymore to be used, you want to discard the product because of its risk involved in the whole process line. So, at what level you are doing FMEA is also to be prefixed before the study starts. Step number 4, based on the experience and understanding of the scaled model, which is possibly a working model, identify possible failure modes. Now, it is very interesting, the model is a scaled model, it is in a working condition, therefore, the model is not going to have any failure mode at all because the model is perfectly working. You have got to perceive this, you have got to assume if a specific component is going to fail, what will happen to the overall performance of the complete model. So, one has got to perceive those failure modes. So, identify these failure modes, the reasons for the failure, that is what we call as the causes, and their consequences, that is what we call as effects on the overall performance of the complete system. System I refer here is electric or mechanic systems, okay, not a chemical or process system, mechanical systems, that is what we mean here. So, in step number 4, you have to also identify the sequence of failure, that is very, very important. I mean, you should identify which component can fail first, why, that is what the cause. If it fails, what will happen, that is what the consequence, what we call as effects. So, you study the sequence of failure, that is very important, step number 4. In step number 5, you identify the failure detection and rectification. What does it mean is, if the system is going to fail because of failure of any specific component which you are perceiving in this step, then identify whether this failure is detectable. Can you physically see this failure? For example, an arm may break in a shaft, a wire may get disconnected in an electric cable or a layout. So, can you physically detect this kind of failure? Is it detectable? If it is detectable, then can it be rectified? Can it be corrected? In step number 6, identify the design changes that are required for those critical components. Also identify the operating provisions that can be recommended to avoid the failure of components. Based on this, in step number 7, prepare a list of recommendations or actions and summarize. So, one can see here there are various steps which are involved in a total FMEA methodology. Some of the steps are qualitative, some of them are quantitative. Let us quickly see which are qualitative. Defining a system is a qualitative step, because you are going to describe the system in terms of its operational features, in the design ideas, shop drawing, etc. You will not associate any number, any numeric value at this level of analysis. The step number 2, you are identifying the functional relationship. Again, this is qualitative, because again you are not going to assign a number to this case. You are going to only identify the performance requirements or design intents. In the third stage, you are going to prefix the level of analysis, what you want to do. Is it in operational stage, is it in modification stage, design stage, etc. This is also qualitative. If you move to step number 4, you are going to identify the sequence of failure. The sequence of failure cannot be identified unless you attach an associate number which can ascend or descend the order of failure. Therefore, this is quantitative. Now, where quantitative is coming into play here? You are going to assign a specific number to the failure identification, detection and rectification. So, on a 10-point scale, you can always identify a number to each one of these components in terms of identification of failure, detectability, occurrence of failure and can it be rectified. So, on a 10-point scale, you assign a number, then you will be able to get in step number 5 what we call risk priority number. Therefore, this is again quantitative, because here you get a numeric index, here also you will get a numeric index. Ultimately, I am converting a qualitative study of performance of a specific item or object or a product into a quantified risk analysis. So, I am connecting qualitative analysis and understanding and interpreting the damages anticipated in the design through a quantified number. Friends, wherever you are looking for a final summary of risk analysis, it should be always indicated in terms of a number. This number can be even probabilistic terms or in deterministic terms, but anything which is qualitative cannot be really ranked. It is very difficult. Okay? You will not be able to relatively compare them and say which is better than the other, because the parameters which are used for qualitatively indexing them may not be common to all those items which you are trying to compare. However, when you convert them into a numeric value or quantify them in risk analysis modes, then you can ascend or descend these to identify the most critical component. That is how the FMEA converts the qualitative observations into quantitative system, and ultimately in step number 6, depending upon the highest RPN number, you are going to identify and recommend the changes. Therefore, this step anyway is quantitative, and of course, this step is only a summary which gives me the recommendation. So, therefore, this has to be qualitative, there is no doubt, but however, this is depending upon the number or the numeric figure, you are going to derive the recommendations and give the actions according to suggested by the committee. So, let us quickly see what would be the system definition means. We all know as the process of oil exploration, production, storage, etc. is highly complex. FMEA is generally done in small steps. As we also understood, hazard study is not done for the entire plant, it is done on segment of the plant, and we already learned how the segmental hazard studies can be integrated for the entire unit in terms of simple software which helps you to connect the database from that of the recommendation made in the first segment of the plant to that of the nth segment of the plant by simply identifying these numbers from the existing database. Similarly, here also one can do FMEA in small steps, then integrate it to the complete extent of the system, and one can analyze the system as failure of different modes or failure of different components of the whole system. So, here the idea is not to analyze the system as a whole, but system as a whole through parts of the system or components of the system. Therefore, one can say FMEA is component level analysis. So, it is very important to know the interaction between the components before we look into the consequence of the failure of these components on the overall performance of the system. So, when you define the system, be very clear in defining the interaction of components, that is very important. Then only you will know, will a component failure lead to cascading effect of the whole system. What we saw in the beginning about orientation of mistakes is nothing but accident or incident. So, that is what we are insisting here as well. So, if you look at the level of analysis, as I said in step number 3, the level of analysis depends upon what kind of functional or structural system you are discussing for FMEA. It is not about the physical component system at all, it is about the functional structure of the system. So, it is the failure mode which is insisted, not the physical system which we are looking at. So, the primary function of a system should be identified, then any deviation from the primary function of the system should be identified through deviations of the components of failure of the system, which can be a subsystem as well. So, one can look for a primary function of a system, one can then identify the secondary function of the system, then if you feel the deviations between the primary and secondary function of the system is going to be affected by the failure of components of the system, then keep on identifying them and ranking them as the most critical component. That is what we call as level of analysis. The level of analysis also means you are bisecting the whole system into various levels of components and diagnosing each component level to find out the consequence of that failure on the overall system. You understand? So, all possible failure modes should be identified. Now, the question is, What are the possible failure modes in a given analysis of a mechanical or electrical system? Possible failure modes of a mechanical or electrical system. The component can have a premature operation. What do you mean by premature operation? Let us take for example a valve. The valve is supposed to open only when the pressure exceeds, let us say, 10 bar, but the valve by mistake has opened even when the pressure has reached 9 bar. So, premature operation, the valve is supposed to open only when the pressure exceeds a certain threshold value, but because of malfunctioning of the valve has already opened prior to the pressure reaching the threshold value. It is called premature operation. The second could be failure to operate when required. What do you mean by this statement? Let us say I need to have a valve which should be opened automatically when the pressure reaches 10 bar. So, in the process line the pressure has reached 10 bar, but the valve has not opened or it is not operated. So, it is failure to operate when required to operate. The third could be intermittent operation. What does it mean is the valve or the component operates at a spurious manner. Sometimes it operates, sometimes does not operate, but the operational conditions are continuously same, but the mechanical fault is there in the component which prevents the operation of the component in a continuous mode. The fourth could be failure to cease operation. When required. Let us again take an example of a valve. The valve should close when the pressure drops below 10 bar. The valve should remain open only when the pressure is equal to or greater than 10 bar in the given process line. So, when the pressure exceeds 10 bar, the valve opened. Then the pressure was controlled with some mechanism or some mechanical means. The pressure dropped down to, let us say, 9.5, 9 bar. At that instance, the valve should close, because the valve should remain open only when the pressure remains at 10 bar or higher. So, in this case, the valve does not close even though the pressure dropped down below the threshold value where the valve should remain operable. So, failure to cease operation when required. Loss of output or failure during operation. Let us say I have a sensor which should glow or which should raise an alarm when the temperature in a given system exceeds maybe 100 degrees Celsius. So, the temperature sensor records the temperature. If the temperature exceeds 100 degrees Celsius in a given system, it should raise an alarm. Okay? But the sensor records the temperature, does not trigger off the alarm system, and the alarm system does not work even though the temperature is exceeding 100 degrees Celsius. Loss of output from the sensor or failure during operation is again a case of failure. Sixth could be degraded output. You want a specific level of output, but you are getting the output, but the output is not satisfactory as level to the performance function of the system. So, these are the possible failure modes which can very commonly occur in an electromechanical systems, which are not very common in case of chemical process systems. So, these are the analysis of failures which are very commonly used successfully in FMEA studies. Now, after identifying all the possible failure modes in a given mechanical or electrical system, then one should also look at what are the possible causes, the reasons for these kind of failure modes to happen, and if they happen, what would be the effects or the consequences on the overall system. So, after identifying the possible failure modes of the components of the system then one should look for what are the causes for such failure modes, and if they fail, what would be the consequences on the overall system, what we call as effects. So, this is what we call as causes. So, one should now look at the possible causes and consequences. Now, the causes and consequences should be looked at both component level and system level. So, this will help you to really find out the sequence of failure. So, if you really wanted to find a sequence of failure, one should establish the cascading effect of component failure on the system failure. So, to understand this, one must know very clearly the interrelationship between the components as well as the relationship between the components and the system. So, both should be understood very thoroughly. Suppose in the process of identifying the causes and consequences, if the system has got an inbuilt safeguard, then that should also be examined. So, any inbuilt safeguard present in the system should also be examined. Now, this will be helpful to really identify any component where inbuilt safeguard is present, then that component will not be in the priority of failure. For example, let us say there are some electrical components where the working of the component will cut off when the temperature rises beyond a specific value, when the input voltage rises beyond a specific value, etc. There is an auto cut-off facility may be available as an input in the design itself. So, if such safeguards are present in the component level, one should also account for those safeguards present in the system, because that will prevent the cascading effect of the failure of the whole system. So, if you really wanted to identify the sequence of failure, one should look at the interrelationship between the components and the safeguards present in the component, which may or may not lead to the cascading effect of the failure of the overall system. So, that is what the analysis of failure means. Once you have identified the consequence, then the sequence of failure and so on, one has got to report the whole document in a standard format. So, let us now talk about reporting. One has to identify the most significant failure in the given system, identify also the existing safeguards and the detection devices are adequate. So, one has got to identify essentially the weak link in the system. That is what we are interested in. So, the report should focus on bringing out explicitly the weak link. What do you mean by the weak link? Weak link is that one which has the highest rank of failure. This will be the most critical component in the overall system. Please understand, friends, the criticality of the component is not because it is one of the most expensive component in this given system. The criticality will come only when the component failure will lead to a largest possible cascading effect, which will lead to the system failure. So, one has got to identify the highest rank of the failure in a given system mathematically, quantitatively, whichever component gets the highest rank of failure, that is what we call as weakest link in the entire system. So, in that case, for the weakest link, one has to do detailed analysis for the maybe the system has to be redesigned, material specification may change, component size may be different, etc. So, one has to do a further detailed analysis. Friends, please understand, FMEA only detects the weakest link. FMEA does not analyze the weakest link in detail for redesign. So, FMEA prompts in a given system which is the most critical vulnerable component. So, it is for the designer to pick up that component, re-examine the design, change the design and then replace it with a new component and then do FMEA analysis. Okay? So, one may also think of redesigning the whole system if the cascading effect is so serious about the design. So, FMEA is available in a specific format like ASAP report. So, the format of FMEA is given like this. You have to say which component you are talking about, what failure mode you are going to discuss, and what would be the failure effect the component will have, and what is the comment or recommendation or action you are going to give. So, that is a simple format which is used for FMEA report. However, in this format, where are we going to convert the qualitative statements into quantitative statements by giving numbers in terms of the order of priority? We will talk about this in detail in the next lecture, but then we will illustrate this by couple of examples, make you comfortable to understand how to prepare an FMEA for a mechanical system which is having a perceived fault. So, in this lecture, friends, I hope you have understood one of the important tool which can be used for hazard indexing or identification for electromechanical systems. So, what are the requirements for doing an FMEA? How an FMEA need to be carried out? What are the different levels where you got to focus? What is the most important item in an FMEA output, as we are seeing the identification and risk indexing? The FMEA should identify explicitly the weakest link so that the component can be redesigned or the whole system can be rethought of by replacing this component by better component in terms. So, we will look into more details of FMEA in the next lecture. Thank you very much.